All right, guys. So the topic for this webinar is scalable visibility and security analytics for your business or for your hybrid and multi-cloud environment. Like I said, we have Omar with us who will be helping us with the Q&A. And today's agenda is to help you guys, understand what visibility means and what benefits you can gain out of getting visibility from your network, and how you can make good use of that in terms of, detecting threats and finally responding to them. So, as part of that objective, we have two products today which we're going to cover. One is Cisco Stealthwatch Enterprise, and we will see the architecture of this particular product. What are the different components? Bill of material, how do you size, estimates, and how do you create BOQ? And then a quick, maybe 10, 15 minutes demo of the Stealthwatch Enterprise, some use cases, case studies, and then we'll get into the another product called Stealthwatch Cloud, followed by a demo and some resources which will be really helpful for you while doing customer meetings. Some use cases you will be able to present to them. We'll see how POV is conducted, and followed by a Q&A. Yeah. So with that, we'll get started. So as we have seen recently there has been so many attacks on various kind of organization, right from public sector to banking to financial, even Twitter and these kind of organization. So what does it suggest? So to me, it looks like we are clearly at war with our adversaries. So we as a defenders, we have to protect our organizations against really sophisticated kind of attacks, which are advanced persistent threats, which are encrypted malwares hidden inside a encrypted traffic. And these probably could be zero-day exploits as well. The main motivation behind adversaries to go after the enterprise is that they are after financial details, they are after PII of companies, and obviously the cybersecurity or cybercrime market has expanded to $6 trillion. Is going to be expanded to 6 trillion by 2021, as predicted by Cybersecurity Ventures and another report from Phenomenon Institute. So that's not all. Although we have so much, security protective solutions in place, but we still see these attacks happening. And why these attacks are happening? Because there is no silver bullet in security, and every protective control will fail at some point of time. And also to the fact that there could be compromised credentials which are available for with bad guys. There are disgruntled employees who knowingly or unknowingly leaking credentials. We have admin privilege abuse happening, and also the fact that some of the products which predominantly companies deploy is primarily to do protection against any malware. We lack a lot of tools when it comes to detection and then finally response. So on an average, what we have seen as an industry, the breach detection time is close to 200 plus days, and it takes close to 73 days on an average to contain a breach. How do you contain? First you need to detect it, and then you need to maybe quarantine and take steps to contain that. So it's a pretty big deal to investigate that. So we want to make that as simple as possible. And for you to also know that average cost of a data breach has increased close to $4 million on an average globally. For our region, which is Middle East, this is highest or second highest in the world, right after United States, which is close to $5 million cost of a breach. So if any breach happens, on an average, companies are looking at spending this much money to overcome that. So one quick example of one such breach on-prem, which happened for one of the prime institutions, military research organization, NASA in US. You might have heard about this. Now, this breach was done by leveraging vulnerabilities on Raspberry Pi. If you don't know Raspberry Pi, it's a credit card size computing platform which gives you full capabilities of a full functional server as such. Now adversaries leveraged this vulnerability, and they were able to get inside their system using this Raspberry Pi vulnerability, and were able to steal close to 500 MB of data from Jet Propulsion Laboratory using this very cheap device, $80 device. And this kind of device was present in the network of NASA, was not even detected until 10 months. So imagine companies like NASA or maybe big organizations in the recent past. We've seen some data breach in Twitter. All of these companies, do you think they not have any protective controls in place? They have all the controls in place, best of the breed. And even they have all the same platforms and everything is in place, but still we see these breaches happening. So that's exactly why we need to have full visibility of our network, and then be able to detect malware in our environment and contain that using incident response mechanisms. So this is a pretty busy slide. I'm not sure if you guys are aware of MITRE ATT&CK framework. So this framework, it's an open source framework developed by MITRE organization, which actually talks about all the tactics and techniques leveraged by adversaries and blue teams as well, to understand how attackers go by their business. What are the different techniques they leverage when they have to implant a malware inside your organization? How do they do lateral movement? How do they escalate privileges? How do they exfiltrate data? So on and so forth. So this is a very exhaustive list, and Cisco is completely aligned, and this particular product is completely aligned to MITRE ATT&CK framework. We will see in the coming slides during the end of the session. And then so what does it mean when I say effective security to you? And how do you make sure that your organization is effectively secured in today's dynamic environment? For you to first of all be able to protect your digital assets, you need to know each and every host in your environment. You should be aware of what's going on, what are the conversation in the network level going on, and then you understand what is normal against what is abnormal or malicious or anomalous. And finally, when you detect anomalous behavior, you should be able to trigger an alert, and which can be taken further by tools like Stealthwatch or any SIM platform to be able to contain that threat very quickly. Now, like I said, during these times already we were expanding to multiple cloud platforms. We were working from multiple data centers, different branch locations. Users were present working from their home, different devices, using different platforms like mobile. There are IoT devices everywhere. So everything contributes to our network, and everything could be a potential, threat vector or could have vulnerability which can be exploited. Now, fortunately or unfortunately, thanks to COVID-19, we all are working from home, and which makes us a little more vulnerable in the sense that adversaries could leverage the weak security measures deployed by companies in protecting their users who are working from home, and that can be a potential disaster for companies. So how do we get all that visibility and then protect you is what we're going to see. This one slide quickly summarizes everything what Stealthwatch, as a security analytics platform does for you. The first step in your security analytics is to get visibility. And how do we get visibility? We collect data using the rich telemetry, exposed by our network, whether it's our servers, whether it's branch locations, data center, or even IoT devices like IP cameras or anything else, even cloud as well. Now, once you've collected the data, what you want to do is do behavioral modeling on that data, which means that do a baseline of your environment, understand what is normal over a period of time, and then finally, once the normal is established, you would understand and create certain thresholds to see if those thresholds are breached. There would be an alert which gets triggered, and then to power that, to make it more effective and more I would say efficient, this product leverages multi-layer machine learning, which is a combination of supervised and unsupervised techniques. So the Stealthwatch Enterprise on-premise components, they leverage unsupervised machine learning, which means that they try to learn on their own from the data they collect. And then to power that, we have Cisco cognitive threat analytics as well, which leverages machine learning, which means that the patterns which we have seen in the past, and we know which is good, which is bad, and which are the malwares associated, and which are the bad domains associated with the malware, which are the Tor connections. all of that information is provided by Cisco Talos, the global threat intelligence platform. And finally, we have done so much, but that's not enough, because recently, last few years back, Google has announced that anything which is not encrypted, any communication which is not encrypted, is going to go down the search history, maybe on the second or third page. So it's kind of seems very mandatory to have our communication over encrypted traffic, which is good for us from a privacy perspective. But again, hackers are also kind of leveraging this security capability. They are trying to insert malware inside encrypted traffic. So close to 60% of the encrypted traffic contains malware today, which if does not get detected by technologies either like SSL offloading or by Stealthwatch, it could be pretty devastating for you as an organization. So it's pretty obvious that we want to look at encrypted traffic as well and see whether there is any malware present in it or not. That's not all, guys. So why should we care about these different technologies? Because our applications earlier, they were developed as a monolithic architecture, or our code was developed as a monolithic architecture, and they were deployed in primarily physical servers, which would scale out or vertically or horizontally, and we could deploy multiple such servers. But then later on, to ease things and to achieve more out of a single hardware, we leveraged virtual machines. And today, when a lot of companies are leveraging microservices to build their applications or web services, they are leveraging microservices. So microservices are very lightweight, components of an application. For example, Uber as an application contains maybe 10 or 15 different microservices. They are independent set of codes deployed on different infrastructure and talk to each other using application programming interfaces. Now, the idea of microservices is to make your application very lightweight, very agile, very flexible, to be able to deploy in any platform and solve your DevOps related problems. So for that, Docker came out with containers, and Kubernetes also came up. And this Docker container is actually an abstraction of your actual code packaged with your application dependencies and different libraries, except the host operating system. Now, the benefit of Docker is that it's so lightweight that it can be spun up quickly in matter of seconds. And then you have something called serverless, which means that you have technologies like AWS Lambda, which is actually going to just consume a code from a user. For example, a developer who wants to deploy a certain application in cloud, they need not worry about what is the database I'm going to use, what is the server I'm going to use, how much CPU, RAM, memory. They just want to deploy their application. So for that, something like serverless or AWS Lambda is going to get leveraged. These are important from other perspective also, because serverless, this entity can be used for maybe, let's say, matter of running 10 seconds, even milliseconds. So the billing is based on milliseconds of usage as well. Now, if you look at containers, you may want to run containers for maybe, let's say, a few minutes. Virtual machines, you may want to run them for, let's say, years or a couple of years. But physical servers, once you have invested on them, it's going to be available with you for a long, long time. Now, with increasing compute flexibility, we are seeing a lot of cost reduction when we move towards the new age technologies. These are some of the stats. And what we have noticed is that infrastructure decrease increases the application, when we leverage the technologies like Kubernetes, containers, and serverless. So, I mean, there is clearly in the physical world or the virtual world, you had an option to deploy certain agents to monitor what's going on. But how do you monitor your workloads in containers or Kubernetes environments, whether it's an on-prem or public cloud? Or how do you monitor your workloads in serverless kind of platforms? Another breach relevant to the cloud is one of the finance organizations. They were leveraging AWS API keys to store the company data in S3 buckets in AWS, and those keys were put by developers, unknowingly in the GitHub repository. And when certain bad actors, they have automated tools to scan through these GitHub repositories, they access these API keys, and they were able to exfiltrate close to 103 million applicants and customer records, which were stored in that S3 bucket, since these GitHub repositories were public, not secured. So with that, We know that there are so many clouds available today, which is AWS, Google Cloud, Azure, and a lot of compute and capabilities like Kubernetes are provided by these cloud platforms. And also we have on-prem environment and on-prem Kubernetes containers and these kind of platforms. How do you get visibility from all of these cloud? Because for you to know that if your cloud environments are secure or not, first step is to get visibility from them. So Cisco Stealthwatch Cloud is one such product which is going to collect data or telemetry from all of these clouds and then give a single dashboard for you to give you end-to-end visibility on all of these clouds as well as on-prem infrastructure. We will see more details on this in the coming slides. So clearly there are two products. One is Stealthwatch Enterprise and the second is the Stealthwatch Cloud. So cloud is primarily used for public cloud monitoring and private network monitoring as well, with a little less integrations when compared to Stealthwatch Enterprise. We will see what are the real differences in the coming slide. Now quickly, let's jump into the Stealthwatch Enterprise here. Um, and the main goal of enterprise, like I said, is to collect the contextual network-wide visibility. And then once you collect the visibility, you do predictive threat analytics using behavioral modeling, machine learning, and global threat intelligence from Cisco Talos to detect, malwares using the telemetry provided or, the alerts, high fidelity alerts provided by Stealthwatch. And then once you have detected those alerts, how do you remediate them really quick? So we will see that as well. So how do we do this is using agentless approach. We just collect the existing net flow capability in your network and collect the metadata, not the actual payload, which contains source IP, destination IP, port, TCP flags, source, security group tags, or application name, these kind of things. So when the telemetry is collected from endpoint A to endpoint B, there are actually, these are unidirectional telemetry records, which means communication from A to B and B to A. Now, what Stealthwatch does really effectively is combine that telemetry and present to you as a bidirectional record so that, we can actually cut the repetitive streams and make your net flow very lightweight or your telemetry very lightweight on your storage as well. So apart from that, like we spoke about encrypted traffic, how do you collect more information without decrypting about any communication which is encrypted and if there is any malware present or not. So this is one of the use cases of detecting malware in the encrypted traffic and could also be used as encryption auditing, whether you're using outdated TLS protocol in your environment or not. So this is leveraged using ETA capabilities of our Catalyst 9K or ISR or ASR, CSR kind of platforms available from Cisco. If not, then we can use flow sensors for non ETA supported products or even third parties as well. So we can collect flow sensor telemetry from flow sensor and leverage that and pass on that metadata, not the payload, to cognitive to come out with a verdict whether this encrypted traffic contains a malware or not. We will see this in more detail. The next is once you've collected the telemetry, how do you make it more actionable? Which means that how do you add more, contextual information from a user perspective? Like for example, which user logged in and which user was logged in on that machine from which this telemetry was collected, or who was part of this particular breach, or whose access was leveraged to conduct this breach, or something like that. And then more, you want to get further more visibility in terms of what applications were being used, what domains, what URLs, all those kind of things. So when you have all of this, then you get a very clear picture of what's happening in your environment. How do you get telemetry is, you can integrate Stealthwatch using PX Grid platform and do integration with Cisco ICE to get some of the additional fields like, device ID, domain ID, SGT tags, usernames, endpoint IP, these kind of things, which will be used and really helpful in, doing detection further. More visibility in terms of URL can be leveraged using integration with flow sensors, leveraging advanced NetFlow or IPFix, and proxy integration using syslogs. Those proxy data can be pushed to Stealthwatch as well, so that you have visibility to what URL was involved when a user was trying to access certain things, when a breach happened, and when they establish a connection to, let's say, a malicious domain. So that can be clearly identified here. So the use case here is reporting internet URL access and detecting control and command traffic, detecting Tor traffic, these kind of things. And finally, you may want to get more information because you would want to know which process within the endpoint or a host started this flow actually, and then also get process hash, process name, parent process hash. So once you have all of this visibility, then you can put it to a good use of detecting threats. And the last piece to full visibility is doing smarter segmentation. Now, using Stealthwatch, in addition to what segmentation you do in Cisco ICE, you can also do segmentation in Stealthwatch Enterprise as well as Stealthwatch Cloud. So the way you classify your hosts, which are IP and subnets, into different host groups in your environment, these could be logically clubbed, as locations or countries or specific use cases. For example, printers group, employee group, something like the confidential server, DMZ servers, like this. So you create two host groups. One is inside zone and one is outside zone. Anything outside your perimeter, like clouds, your partner networks, everything in the internet is an outside network. Now, what you do is you monitor these hosts and any activities happening from these hosts to the other host internally or externally, and baseline the behavior of traffic over a period of 30 initial few days, and understand what is normal versus what is not normal. And when the threshold is breached, the system creates an alert which can be used by Stealthwatch to do further actions. Now, there are 4 ways to segment our networks into different host groups using manual host group creation, or you can leverage APIs using IPAM, maybe from Infoblox or something like that, host classifier applications or maps. These kind of applications are available today. So the use case here is using Stealthwatch for network segmentation and policy development. This is how exactly you create host groups within your Stealthwatch enterprise. Club your, create a logical grouping of your host and subnets into different, groups, and assign IP addresses, including a complete range or a single IP, and then enable baselining and let the system automatically detect a normal behavior. And we can create policies to understand if there is any breach from normal, and then quickly create a high fidelity alert for you. Like I said, automation can be done to create host groups using Infoblox integration with the help of APIs available on Stealthwatch. You can integrate with SolarWinds. You can leverage anything basically which is used as your IP address management repository or a tool, or you can even leverage your Excel sheet where you maintain your enterprise IP addresses, where you plan all of your IP addresses, and that can be integrated here. So this is really important, guys, because this is a fundamental block of Stealthwatch. What we are trying to do here is that create host groups and then understand what is normal, and if there is any deviation from normal, create an alert, so that we can understand that this is anomalous using behavioral machine learning capability. So this is the map I spoke about. So Stealthwatch today has a beautiful map, which you can create maps from at different locations where you have presence, and then understand the overall flow of traffic from one location to other, and also understand different kind of map. You can leverage them to create network performance. You can understand RTT, SRT, overall traffic bandwidth from one location to the other. You can generate alarms by leveraging these maps, and then creating policies on the fly, and making really good use of these maps to one, get visibility in a really visual way, and also remediate threats automatically using the policies which you create. And the next piece after visibility is the analytics. Now, once we understand complete visibility of our environment, the first step is to do baselining and understand what is normal behavior versus what is not normal, what is anomalous. Now, this we discussed, we are going to create a baseline of our data over a period of initial, let's say 30, 36 days. And then we understand that, okay, this is normal versus not normal. And we create a threshold, and anything which spikes out and breaches threshold set by us is going to generate an alarm. Now, how does this actually works? Using behavioral detection mechanisms in Stealthwatch, there are so many, close to 250 plus security events like address scan, bag flag, beaconing host. Beaconing host means that any malware, when it's first installed in any systems, it is going to beacon out and try to reach out to its control and command center to further pass on more, commands to this malware to do what the C2C wants it to do. So once you have anything, breaching that threshold or matching any of these security events, there is a automatically alarm gets created in the system. So there are close to different 11 alarm categories, right from reconnaissance, C2C alarm, exploitation, exfiltration, DDoS target, policy violation. And as a response to these alarms, we can, pass on that to as a notification to an email for analyst to see what's going on and try to contain that, or pass on these alarms, high fidelity alarms, to using syslog to a SIM platform, or even do direct mitigation from Stealthwatch itself using Cisco ICE integration. We will see that. Now, the use case for Stealthwatch here is encryption auditing. Now, we spoke about Stealthwatch. One of the unique capabilities of Stealthwatch is to be able to do encrypted traffic analytics, which means that ability to identify malware present inside an encrypted traffic. How do we do that? So one of the key components of that, any encrypted traffic has an initial data packet. Now that data packet contains a lot of good information like IP header, TCP header, and then TLS headers or TLS version, the SNIs. So SNIs gives you all the good information about what is the domain the packet is trying to go to, and what is the domain this particular flow is leveraging, these kind of things. And then you also have a definite pattern of every kind of different traffic flowing out there, whether it's in your network or over the internet. For example, you will see a definite pattern for Google search, which will look something like this. And you will see a definite pattern for control and command center, which will look like this. And then for exfiltration and key logging kind of pattern, it will completely look like this. Now, with the help of initial data packets and identifying the size of the packet and the timing differences between the packets, and along with cognitive threat intelligence, which is machine learning based platform available from Cisco on the cloud. So what we do here is that we collect all that ETA enabled data from our environment and pass on just the metadata, not the payload, to Cisco Cognitive Threat Analytics engine. And then it will come out with a verdict that, okay, with 100% accuracy, that yes, this particular encrypted traffic contains malware for sure. So this is the use case where you detect malware in encrypted traffic, as well as can be used to detect encryption auditing as well. So you want to see, which applications or which flows in my environment contain TLS 1.2 or lower, which is obviously because you don't want to use them because they are deprecated and no more being used or no more considered safe. Obviously, threat intelligence plays a key role here. Talos knows about all the Bogon IP address ranges. It knows a huge list of control and command connections, Tor entry and exit nodes. So it will automatically alert you and help you, come out with high fidelity and confidence that, okay, this particular has a definite malware present inside it. Now comes the response piece. We have seen the visibility portion. We have seen how do we detect, using behavioral modeling and multi-layer machine learning, how we detect threats, and then how do we do response. So, so the use case here is to detect top alarming host on your network. So, Stealthwatch UI gives you a beautiful dashboard. We will see this in the coming slide, which gives you top 11 alerts, including concern index, target index, target reconnaissance, C2C, policy violation, exfiltration. So these are really important. Also, top alarming hosts, which you can further investigate and see whether there was anything malicious going on. And when it comes to remediation, either you can pass on that inputs to something like a SIM platform, or you can natively do remediation from Cisco Stealthwatch using ICE integration. So in Cisco Stealthwatch, if you integrate with ICE, you have an option within the host page to automatically quarantine that particular host or unquarantine if it is already quarantined. If you see that, okay, this is no more malicious, so you can do that. This we have seen, I spoke about this, crypto compliance reporting. This use case here is to how do we detect, encrypted traffic in our applications which are not leveraging TLS 1.3. And then just to summarize, what we have seen so far is some of the key features here. Number one, obviously, is visibility everywhere. You want to know what is going on across your environment, whether it's a branch or a data center or a remote location, a user working from home, or applications in cloud. And then once you have visibility, you should be able to uniquely detect threats using a combination of behavioral modeling and multi-layer machine learning in the platform natively built, and as well as machine learning available with Cisco Cognitive Threat Analytics. And also, you should be able to detect encrypted traffic which contains any malwares, again using CTA, and high fidelity inputs collected or telemetry collected from the core Cisco routers, switches, and flow sensors as well. Now, once the encrypted traffic is detected, or once the threat is detected with high fidelity, the next step is to do actually smart segmentation. We've seen that create logical grouping of our network and understand if there is any flow flowing from, let's say, one domain to other domain, which should not be happening. Or if you see that, for example, a user never sends traffic to, let's say, China or Russia, when you suddenly see that there is a traffic going from our data center to China, and immediately it will throw an alert using the policies which you created in the Stealthwatch. Again, last piece is remediation, which is really important, because if you just do detection and don't remediate, then probably the malware would start spreading in your environment by doing internal recon and doing privilege escalations and so on and so forth. This actually summarizes on a high level that the entire process. For example, there is a host which does data hoarding and at the same time does the data exfiltration. So with the help of telemetry collected and predictive threat detection mechanism, we are able to generate alarms on Stealthwatch. Once the alarms are generated and the device is identified, and using additional telemetry from let's say Cisco ICE or NVM module on Cisco AnyConnect, we are able to identify which user was creating that kind of alert and where the data is going because it's getting exfiltrated. What kind of data was that, whether it was data related to something PII or any other regular data. And then once we have seen all of that, we know all of this is happening, and we quickly want to remove that threat from the network, and maybe at the end of the day want to do forensic investigation. So the whole idea is not only just detect threats, but detect the threats which gets which penetrate your network, bypassing your protective security controls. How do you quickly detect those threats and then respond to those threats from months to maybe matter of hours, or even maybe a day or so. So that's the whole idea of Stealthwatch Enterprise. One question which I've seen a lot, and probably Umar also get this a lot, that this looks like very similar to a SIM platform, because SIM also does event collection, and it also does so many other things which look a little similar to a Stealthwatch, but it is not. If you ask me, it is actually going to complement your SIM platform. So Stealthwatch is a way to reduce your volume of flows being sent from Stealthwatch to SIM. So what we have noticed is there is a white paper available on this. We have seen that close to 80% of savings when you send just the raw logs to SIM versus when you send high fidelity alerts from Stealthwatch to SIM on the overall storage cost as well. So there are two scenarios. One is Stealthwatch data optimization, which I just spoke about. using Stealthwatch, not all SIM solutions, I don't think any one of them does data deduplication, but Stealthwatch does a lot of data deduplication. It is only going to send you a unique flow from your environment, which on an average does 6:1 reduction of flows, which is close to 84% less flows which you're sending to a SIM platform. And then second use case is that since Stealthwatch is able to get so much visibility, it uses machine learning and behavioral modeling techniques, it is able to create those high fidelity alerts in your environment, which can be quickly passed on to a SIM platform using webhook integration or using APIs or using syslogs. Anything can be leveraged. And then a security operations center agent or analyst can look at those high fidelity alerts and start doing response and remediation from SIM platform by leveraging the endpoint, point security controls as well. So guys, please feel free to ask your questions to Omar. He's there to help us. So before we move on to the demo, I just want to quickly, obviously you guys are a little curious to know how does this thing work? What does the architecture look like? How do we create the BOQ and so on and so forth? So for Stealthwatch on-premise, the main core components of Stealthwatch and the mandatory ones are Stealthwatch Management Console, which is this guy in the middle, and then a flow collector, which is going to actually collect the flows from your environment, normalize them, deduplicate, and process them, so on and so forth. And you have a threat intelligence license. By the way, this is optional from Cisco Talos. This is required mainly to when you want to get Bogon IP address range, C2C, Tor related information, all of that. So you can leverage this. And cognitive threat analytics engine is also there, which is going to give you with high fidelity that, okay, yes, this contains virus inside encrypted traffic for sure. And the other components are flow collector. Like I said, it's going to collect telemetry data using NetFlow, SFlow, JFlow, IPFix, and so on and so forth. But the preferred way to collect data from customers' environment is NetFlow and IPFix because it's not a sample data. When you look at SFlow and other flows, they are kind of sampled. They don't give you a full picture. When it comes to security, NetFlow gives you much more data, to you, which can be leveraged from a security perspective. Also, some of the Cisco existing ETA enabled devices like Catalyst 9Ks, ASRs, CSRs can send you encrypted traffic analytics related data, which is enhanced NetFlow and can be leveraged to do encrypted traffic analytics or detecting malware inside a encrypted traffic. Furthermore, there are going to be certain dark areas in your network where NetFlow is not supported. Probably these are some older devices or some third-party devices which do not support NetFlow. For these environments, we have an optional component, or this could be mandatory as well in certain cases when you want to get more visibility. But the recommendation is to also deploy these just to get more visibility from an application standpoint. So what this guy does is that it collects flow data or collects the data from all these non-NetFlow supported devices and converts that into a NetFlow stream and ETA and adds ETA tags to that as well. Again, this flow sensor can be deployed in a virtual environment as well. So all of this info can be passed on and leveraged by CTA to detect malware. Additionally, you can leverage UDP director, which is nothing but sort of a proxy in between, which is going to collect data from these sources. And then when you have two sources of data, if you want to send this flow information to, let's say, your monitoring solution, SolarWinds, and at the same time want to send this to Stealthwatch, you can leverage UDP director to send out two streams parallelly at the same time to two different devices. You can do proxy integration for more web context to it. And then at the end of the day, if you want end user related information like process hash, process ID, parent process hash, ID, all these things can be enabled using AnyConnect module, network visibility module. And finally, this is some more details on flow sensor. So what additionally it does is that it's going to provide you ETA enhanced NetFlow, layer 7 application visibility. It gives you round trip time, server response time. So this is again RTT and SRT is also relevant for your networking teams as well, because Stealthwatch, we have seen that it is leveraged heavily also on the network side as well to understand the traffic flow, traffic pattern, what is the server response time, round trip time, on all those things. Not just a security use case, but a network use case as well. But it is a product which is heavily focused on security, as a functionality. So where do I need flow sensors? Like I said, dark areas of your network where you do not have net flow visibility, no native net flow export capabilities on certain devices, only sample net flow is available from your environment, probably at the edges of your WAN network or maybe DMZ. These are the places where you want to collect this information. Of course, for the reasons because you want to collect the ETA, encrypted traffic analytics, so that you can detect malware inside the encrypted traffic without decrypting it. Unlike other solutions like, maybe SSL offloaders, maybe F5 or any other product which will require you to offload that packet, which is again a cost as well, and also may not be relevant in a lot of companies because of the compliance reasons, or you may not want to decrypt the banking information of some critical people in your company as well. So you would need this flow sensor as well. And some of the other integrations with Cisco Stealthwatch, which are really important, is integration with proxy, DNAC, AnyConnect, ICE, API-based integration with third-party platforms like ticketing platforms, GuardDuty, or maybe you want to integrate this with your WebEx or Slack community for your incident response team to effectively communicate between them. You can integrate with Palo Alto. You can integrate with SecureX. This is really interesting. You will see this SecureX integration, how you can automate an incident response using complete workflows. And then you can also do API-based integration with Meraki and Umbrella to do, collect external information like host name of an endpoint, or collect, for example, do external lookups of certain URL or a certain IP within the Umbrella Investigate dashboard, and you can check there as well using this. So like I said, integration with load balancers. This product can be integrated, a flow sensor can be integrated with load balancers. The interesting thing about load balancers is that any traffic which passes through load balancers is actually going to create two streams, one from the actual user to the load balancer and from load balancers to the destination. So what happens here is that as a nature, by default, load balancer will pass on the load balancer's internal IP to the destination, which is the internal network. If required, you can leverage X forwarded header capability of a load balancer, pass on flow data, which includes the end user IP as well. Is there a question? I see somebody asking. Okay, I guess no. All right. So this is why you would integrate with a load balancer. Just one sec. Let me mute everyone. All right. Then you can also integrate with proxy to get more contextual information, wherein URL related information. You can integrate with Cisco WSA, Blueport proxy, Squid, or McAfee. Any of these proxies integration is possible. We've seen this AnyConnect network visibility module integration. We'll skip through this. This is interesting. You might have heard a lot about Cisco SecureX in the recent past. So this is one such platform which has hundreds of use cases. And I really like about this platform is that it is not just a security platform. To me, it's a single pane of glass which you need in your organization, which will not only give you security operations, IT operations, and network operations capabilities, with the ability to create automated workflows. There are hundreds of workflows pre-created by Cisco for you, so that you can do complete incident response, automation, remediate threats, all those things, so on and so forth. So it has got its own inbuilt case flow engine, ticketing platform, integration with ServiceNow. You can leverage the APIs to integrate with third-party ticketing platforms, or so on and so forth. So it's a really nice platform. And how this can be integrated with Stealthwatch is that it actually leverages APIs. So RESTful APIs you can leverage them and put Stealthwatch as a dashboard inside SecureX as well. So these are the top categories which can be inserted inside SecureX dashboard from Stealthwatch. We will see one quick use case of protecting remote workers with SecureX network detection and response capabilities. So the use case here is that how do we automatically protect a user working from home when a threat is detected on the user's machine? Typically in a normal scenario, what you will do is that alert is created on a user's machine. The endpoint security will generate that alert, pass on that alert to a SIEM platform or a SIM platform where an analyst will go through that. It will take its own time to understand whether it's false positive or genuine or not. And then at the end of the day, they will do a manual remediation, or maybe they may leverage some other security operations and automation response platforms. But SecureX by default can create a workflow from you when the telemetry is collected from the user, whether it's corporate or home. And also after collecting user and file context data from the AnyConnect NVM, a workflow can be created. This metadata is passed on to SecureX, and a workflow is created, orchestration workflow is created to automatically isolate that particular machine which contains a malware in your network or a user working from home. And within this workflow, it's really flexible. You can
Nirmal, this
insert
is
a
for
step.
VPN users also.
Yes. So
It is
actually, this
agent
is
or
to be
agentless.
okay. So let me put it again this way. This is a automation orchestration platform, okay, which is available as a web UI for you. So this is not any endpoint platform. SecureX is a orchestration platform or a security operations platform for you, which a user will use to do incident response, right? Now, at the end of the day, to detect that actual threat, you will need all those security controls like AnyConnect or AMP4 endpoint, these kind of platforms. Now, what this tool is doing and what this use case is telling is that any remote users working from home or using a VPN, if it contains any threat, how you can automatically quarantine that endpoint without doing any manual intervention. So the way you do it is that you create a workflow within SecureX threat response, which will make sure by collecting all of this telemetry, which we saw from Stealthwatch, and with high fidelity, when Stealthwatch says that yes, there is a threat present in this machine, that information is passed on to SecureX and is leveraged on the workflow